making a simple infrared sensor circuit or flame detector sensor using these electronic components. I'm using a Mosfet ERF-Z44 and you need to use this Mosfet. I try with NPN transistor, it's very difficult and complicated. One LED, one resistor for the LED, one 5-volt buzzer, active buzzer, one, this is crucial electronic component, it's infrared LED, and one 4.7 mega ohm resistor. Let's build the circuit. First I'm gonna solder the 4.7 mega ohm resistor and it's soldered between gate and source of the Mosfet, and it's going like this. Okay. Pay attention that the infrared diode, the polarity need to be like this. The positive go on the gate and the negative leg of the diode go on the positive. Remember that. This is the last electronic component, the resistor for the LED. And I'm ready. Let's try. Don't forget to subscribe to my channel because I upload new videos almost every day. Also, you can watch this electronic insect how I made it. Just visit the link in description. Thank you. Yes, the circuit works on 5 volts. Here you connect positive and here on the source of the Mosfet you connect negative 5 volts or ground. Let's do it this way. Okay. And first I'm gonna try it with testing the remote control. Yes. Working great. And now the flame. Working. What? How is this possible? This infrared LED maybe is magical. Look, I'm not holding the lighter in front of the LED. Behind. Sorry, how is that possible? He is detecting everywhere. Now I light 1 meter from the circuit. This is amazing. How is that possible? I can't explain myself. If you know why, please comment in below and tell me what you think. Alright. This infrared sensor circuit works very well. And look, it's not detecting nothing, any movement, but the infrared light from the lighter, it can be detected. Whoa, this is super cool. By the way, I have a bunch of these infrared LEDs. I bought it from online. $3, 100 pieces. And here it is, the circuit diagram. If you want to To take it, just pause the video and take a screenshot on your mobile phone. As I said, you need only 6 electronic components: the Mosfet, 4.7 megohm resistor, 1 kilo ohm resistor for the LED, 1 active buzzer 5 volts and 1 infrared LED. That's it. Using these 4 electronic components, I'm gonna show you how you can build a cool circuit that anyone can build it. Let's start today's video. Meet IRFZ44N Mosfet transistor. And what is this electronic component? The IRFZ44N is a Mosfet power transistor made by Infineon Technologies. It's known for its capacity to switch high voltage and current levels. Mosfet means metal oxide semiconductor field effect transistor, a transistor type that has low resistance to output and high resistance to input. It has 3 pins. The first one is gate, the middle one is drain, and the third one is source. And I'm gonna show you today's project and explain the circuit diagram. It's super simple circuit for making an on-off touch switch using only 4 components: the MOSFET, 2 diodes and the light bulb. Okay, pay attention on the diodes. They are opposite with poles and they are connected on gate. The drain goes through the light bulb on positive 12 volts, and on source we have ground. When you touch the one diode, the bulb will turn on. When you touch the other diode, the bulb will turn off. Let's build this circuit and see will it work. Okay, let's try it. On the third pin, we connect ground, and on the bulb positive. Turning on, yes, turning off. I can't believe it. It's so simple circuit. Touch switch, on, off, on, off. Working. If I touch it, both of them. Alright. Turning on, turning off. This is so cool. I'm gonna measure the voltage just to see. Here we have 10.4 volts, and when it's on, I'm gonna measure 10.3. This is super. Alright. Off. if I touch the negative. Alright, if I touch the positive, this is cool. Let's remove the bulb, and I'm gonna place a buzzer. Will it work that? Whoa. Okay. And then here we have ground. I reduced the voltage to 5 volts, and now we're gonna see does the circuit work on 5 volts. Okay. Yes. Working. So the circuit worked from 5 volts to 12 volts tested. Alright. One more test. I'm gonna try with the DC geared motor that I have right here. Okay. And positive go to the wire of the motor. Is set on 5 volts. Turning on. Whoa! I like it. I hope you like today. Very simple touch on off switch using this Mosfet. Yes, I'm gonna desolder the transformer from this board. This board is from mini TV, but we'll do the job. Just to pull out from the board, and I'm gonna show you the next step. Also, I don't need this wire. I'm gonna solder another. Using only 3 parts or 3 electronic components, you can make a high voltage plasma generator. Yes, you will need one resistor 200 ohms, one Mosfet transistor. I'm using Z44N, and the transformer that I pull out from the board from the old TV. Before assembling everything, I need to tell you how to add the coils on the transformer. It's the simplest circuit diagram for making a high voltage plasma generator, and you can see I have already wound the copper coils on the transformer, and here it is the transformer. You need to wind 3 turns from the copper wire, connect them together, and proceed to another 3 turns and end. We have beginning, 3 turns, middle, 3 turns, and end. On the middle you will connect positive 5 volts. On end we'll add the resistor that is connected to the gate of the Mosfet. The drain from the Mosfet is connected to the beginning of the coil. Ground goes to the source of the Mosfet, and positive, as I said, on the middle of copper wires. And this wire will generate the arc. I'm just gonna solder right here the wire, and you will see how it's working. Little bit dangerous. Please do not try this at home if you don't know what you are doing. That's why I'm gonna show you how it's working. Okay. So, soldering the end of coils to the resistor, going to the gate. Now the middle leg from the Mosfet go to the beginning of the coil. Come on, man. it's solid, yes. Okay, here go positive, here go ground, 5 volts. I'm ready. Okay, everything is okay. I set my power supply to 5 volts, and to mention, this will draw a lot of current, so I limit to 2 amps, and the negative go right here to mention, and the Mosfet needs a heatsink, and the positive go here. You can see it's pulling 2 amps and the voltage dropped to 4.2 volts. And take a look. Wow! Also you can hear the sound. I need to turn off the lights so you can see better. A small plasma generator with high voltage. I do not recommend to touch that. It will hurt a lot. I have a generator and having a good time playing with this. Okay, what will happen if I close the C-fill bulb? What? This is cool. Still 2 amps, and by the way, you can start a fire. Look, a fire using a plasma generator. Alright. Now I'm gonna try to start the match. Yes! Alright. This is super fun and dangerous. Please do not try this at home. I hope you enjoyed today's experiment, and this is blowing my mind. Using only 3 components or 3 parts to make this plasma generator. The transformer, the Mosfet and the resistor. Alright. I will make more experiments like this, for sure. Using these 5 electronic components, in this video I'm gonna show you how you can make a voltage regulator using a Mosfet and only 2 buttons, one for up and one for down voltage. Okay, let's start today's video. Here it is, the schematic for building this voltage regulator using 2 buttons and Mosfet transistor, and in this case I'm using ERF Z44N Mosfet, one capacitor of 1000 nanofarads, one resistor 4.7 mega ohms, and 2 buttons, one for down and one for up. Here go the voltage in, the ground, and the voltage out. The positive is taken from the same wire, but the ground will be given by the drain of the Mosfet, and across this output you can connect a voltmeter so you can see the adjusted voltage. Simple circuit for making a voltage regulator using 5 components. 1, 2, 3, 4, 5. Let's build it. I'm finished with building this super simple regulated voltage power supply that can be controlled using these two tact switches. Also, I have added a voltmeter, digital voltmeter across voltage output. Maybe it's confusing, but it's simple. We have 2 wires for voltage in and 2 wires for voltage out. The positive wires for input and output are soldered in the same spot, but the ground voltage input go on the source of the Mosfet, and the output ground is coming from drain of the Mosfet right here. Turned out pretty cool. 1, 2, 3, 4, 5, 6. 6 electronic components or parts for making this adjusted voltage power supply. And you can see on this skeleton project how everything is wired. Let's test it now. I'm gonna connect voltage input of 15 volts. Okay, and right away we have output of 11 volts, and must mention the Mosfet can handle maximum 55 volts DC voltage, and the maximum current is around 50 amperes at 25 degrees. When the Mosfet is 25 degrees, at 100 degrees the Mosfet will deliver around 35 amperes. That says on the specs 11.2. Okay, let's try it. I'm gonna press the down voltage button, and you can see that the voltage is dropping, and when you press the another button the voltage will increase. Here it is, maximum 15 volts. I'm gonna hold the down button, and let's go to, for example, 6 volts, maybe 7, I don't know. Okay, I'm gonna hook up a small bulb and increase the voltage. Working great. That's low voltage. It's a little bit slower, but it's working fine. And this LED voltmeter, because it's 2-wire voltmeter, will work with 3 volts, I think. 2 point, alright, 4.8 volts. Let's try with another device. Let's try this gearhead motor. I'm set on 5 volts. Working good. Using a multimeter, now I'm gonna measure the voltage. Is it the same with voltage regulator? It says 4.02, 4.02. I'm gonna increase a little bit. 8.34, 8.35. It's good. Increasing a little bit more. 11.6, 11.6. Working fine. And this circuit using a Mosfet and regulating the voltage using 2 touch switches. It's good and I like it. And I hope you learned something new in today's video. Using 5 electronic components, in today's video I'm gonna show you how you can make an interesting circuit or project. Let's start. I love to play with this Mosfet. It's very powerful. It's ERF Z44N Mosfet that can handle, I don't know, maybe 40 amperes. But it's useful for many beginner electronic projects. And in today's video, using this Mosfet and one electrolytic capacitor of 470 microfarads, one buzzer, one resistor 150 kilo ohms, and one touch switch, I'm gonna show you how you can make a very simple timer. Yes, a timer. Let's build the circuit now. Three pinouts: gate, drain and source. On drain I solder the buzzer with negative side on the buzzer. Adding a touch switch between gate and positive side of the buzzer. Adding a 150 kilo ohm resistor between gate and source. Soldering the electrolytic capacitor with positive side going on the gate and negative on the source of the Mosfet. Alright, and I'm finished. Using 5 electronic components I made a very simple timer. Okay, here it is, the very simple circuit diagram. The buzzer is connected on drain with negative side. Positive side of the buzzer go to the positive 12 volts. With touch switch we trigger the gate and charging the capacitor, the electrolytic capacitor and the resistor in parallel. They are connected on gate and source. Ground goes on source of this circuit. And here it is, I have built it and now I'm gonna test it. Sorry, the circuit works on 5 volts but can work on 12 volts if you use another load, for example a bulb, but in this case I'm using a 5 volt active buzzer. Okay, positive goes here and negative here on 5 volts, and when you press the touch switch it should stay on for around 15 seconds. 15 seconds to discharge the capacitor. I'm gonna measure with my stopwatch. Yes, it stopped. Reset. Start again. Eighteen, 19 seconds. Okay. So you can play with the capacitor and the resistor if you want to increase or get lower time. For example, if I want this to be a timer of 30 seconds, I should use 1000 microfarads and leave the resistor as it is. You need to play with these two electronic components so you can get the right time. But it's simple. With pressing the tag switch, we have a timer using a Mosfet and can be controlled a very high power loads, for example motors or high power bulbs. Yep, turning off, working like a charm. That was all in today's video. Thank you for watching. Please give a like, share and subscribe to my channel. See ya!